All right, so lesson 6 is this is our last lesson in our quadratics unit, and we are going to factor quadratics again today. And one thing that's different with this lesson compared to the previous one is that there's going to be a coefficient, a number in front of the squared term. So we're going to talk about the strategy with how to factor those types of quadratic expressions. So again, as always, follow a lesson, take notes in your notebook, and then when we're finished, you'll get some time to work on today's worksheet, which is the lesson 6 worksheet. So I will let you get caught up and get your paper labeled for lesson 6. And then in just a moment, we will move into our examples. All right, so again, lesson 6 quadratics, factoring ax squared plus bx plus c. Again, that a is going to represent a coefficient other than 1. If you think about what we talked about the last class, is that x squared term was plain. There was no number in front of it, so it was understood that the coefficient was 1. Today, we're going to take it a step further. So we do have some steps that we are going to follow with factoring quadratics that are in the form of ax squared plus bx plus c. The first thing that we are going to do is factor out the greatest common factor if possible. So we did greatest common factor a few lessons ago. It's kind of like simplifying fractions, right? So if you had 3/9, it would simplify to 1/3. So that's the first thing that you want to do, is factor out anything that you can out of each of those terms. Now, that greatest common factor has to be true for all 3 terms in the quadratic, meaning if you had something like 4x squared plus 12x minus 7, I know that 4 and 12 are both divisible by 4, but because 7 isn't, I'm not going to factor a 4 out. So that greatest common factor has to be there for all 3 terms in that algebraic or in that quadratic expression. So we're going to make a diamond problem like we did before. Okay, but it's going to be slightly different. The diamond is going to be slightly different than what we did the previous lesson. Remember, the previous lesson for the diamond problem was you find 2 numbers that multiply to make C that add up to B. The thing that makes it different, there's a slight difference when we have a coefficient of that x squared term, and we'll talk about it shortly. Then we're going to talk about this generic rectangle again today. It's been a while since we've talked about it, but we're going to talk about the generic rectangle, and we're going to use that to help us factor these expressions. And actually, the generic rectangle, if you remember, was just like using those algebra tiles to make the rectangle underneath that little T-chart. And that's going to help us figure out what our factors are going to look like. And then again, remember, the factors are going to be inside 2 sets of parentheses. And what's different with this lesson today, you're not just going to automatically put an X in front of each set of parentheses. You have to wait until we factor out that generic rectangle. Okay, when you're ready for me to move on to our first example, if you could click your raise hand button so I know you're ready to move on, that would be great. A lot of kids gone today. Are my Emmas on here today? Either Emma on here today? Emma. All right. Oh, Emma M, you are here. Again, click the little raise hand button when you are ready for me to move on, please. All right. Most of you have your hands up, so go ahead and put your hand down, please. We'll move on to our next example, or our first example, I should say. So here's our first example. We're going to factor 6x squared plus 66x plus 60. And again, here on the left-hand side, this is just a reminder of those steps. We're going to factor out the GCF if possible. We're going to make a diamond. We're going to fill in a generic rectangle, and then we're going to come up with our factors. So these 4 steps are the same as the 4 steps on the previous slide. So 6x squared plus 66x plus 60. Go ahead and put your raise hand button down, you guys. What do you notice about 6x squared, 66x, and 60? Is there a greatest common factor? And if so, what is it? Yep, you got it, Amelia. So what we're going to do is take a 6 out of each of these, factor it out, meaning divide each of those terms by 6, right? And so we talked about earlier, when we factor out a greatest common factor, you literally are going to divide each of those terms by that greatest common factor from there. And notice the GCF is going to come outside the parentheses. And then 6 divided by 6 gives us that 1x squared. 66 divided by 6 is 11. And then 60 divided by 6 gives us the 10. So that's the first step. Now, I will tell you, not all of the algebraic expressions are going to be able to have a GCF pulled out, but that should always be the first step for multiple reasons. But another one is it actually is going to make your numbers easier to work with as you are solving these or factoring them. Now, if you take a look closely at what we have, then you're going to factor out what's left of that simplified algebraic expression right here, x squared plus 11x plus 10. And actually, if you look at this one, it's a lot like what we did in the previous lesson. So we need 2 numbers that multiply to make 10 that add up to a positive 11. So if I could get someone from Jessica, Lily, Batsaida, Matthew, or Eitzel, if one of you could please tell me what 2 numbers are we going to use that multiply to 10 that add up to 11? Great, thank you. All right, so that's exactly it. So on your paper, what I want you to do is draw that diamond problem and put your 10 and your 1 there. We're going to end up with this one, because once you factor out that 6, in this case, that coefficient became that imaginary 1. So all you're going to do from here is write that factored expression, because we don't need to do the generic rectangle. We're only going to do the generic rectangle if there is still a number in front of that x squared. So because it's an imaginary 1, then we can just write our factors as x plus 10, x plus 1. And then also, just as a reminder, you can switch the order of where the 10 and the 1 are, because multiplication is commutative, okay? All right, when you're ready for me to move on, go ahead and click the little raise hand button so I know that you are ready to go. All right, most of you are there, so we're going to move on to the next example. All right, so this time we're going to factor 3x squared minus 13x plus 14. So go ahead and write that down. You can unclick your raise hand button as well. Giselle, good morning. Glad you made it. All right, so 3x squared minus 13x plus 14. So the first question you ask yourself, is there anything I can take out of 3, 13, and 14 in terms of a greatest common factor? Let's go with Emma, Ymir, Chloe, and Kenzie. One of you, please. Emma M. Is there anything we can factor out of 3, 13, and 14? Can we divide 13 and 14 by 3? Like if you do 13 divided by 3, does it give you a whole number? And if we do 14 divided by 3, is it a whole number? Hello? Hello? Well, there's more than just you. Emma M, Ymir, Chloe, and Kenzie. Is there anything we can divide 3, 13, and 14 by? Well, 3 is prime, so it's only divisible by 3 and 1. Does 3 go into 13 and 14 evenly? No, so the only thing is 1. So we're basically going to say there isn't anything for us to pull out because it's not going to make any difference to just factor out a 1 because it's going to be the same thing. Okay, so in this case, we're not going to pull anything out because 3 is prime and none of those other numbers are going to be divisible by 3. So now here's the difference with the diamond problem. Once you have a coefficient here that is other than that imaginary 1, yes, you're still going to do the multiplication, but you actually have to multiply A and C. So 3 times 4 gives us 42. So 42 turns into this top number. Okay, 42 turns into the top number. So in the diamond problem, when there's a number in front of the x squared, you have to multiply the coefficient of the x squared and that plain constant together to get this number in the top of the diamond problem. Then we also know that we need 2 numbers that add up to that negative 13. So this part is different. You still need to look for 2 numbers that add up to that middle term. So that being said, we need 2 numbers that multiply to make a positive 42 that add up to negative 13. We talked last week when your product is positive and your sum is negative, we need 2 negative numbers. So I need someone from Evan, Ashley, Jesus, Jayla, and Giselle to tell us what 2 numbers are we going to put here that multiply to make a positive 42 that add up to negative 13. Yes, Evan, thank you. All right, so I'm going to move my little blue square here and my pink square. The 2 numbers that we are going to use are what Evan said. So go ahead and put those numbers in there. Now, again, like I said, what's different with this lesson is we're adding in this generic rectangle piece. So once you know the 2 numbers that you're going to use, you're going to draw a generic rectangle. And here is your generic rectangle right here. So what's going to happen is you're going to take your ax squared term. So in our original problem, that's 3x squared. So it's here in the top left. And then your c, right, the plain number is all by itself, is going to go in the bottom right. And that's this positive 14. And then what we're going to do is use these terms right here, and they're going to go in the other corners here in the generic rectangle, except you're going to put them with an X. So you'll see that I've got negative 7x and negative 6x. So go ahead and copy that down. Take a moment and copy this generic rectangle down, so you have that as well as a reminder. And then what we're going to do, as you're writing that down, then what we're going to end up doing is looking at both the column and the row, and we're going to pull those greatest common factors out. So if you remember when we did algebra tiles, we talked about which algebra tiles would we lay going across once we knew what was underneath that T-chart, and which algebra tiles we would put here once we have that T-chart as well. Okay. So let's see, I don't think I've called this row yet. So Sophia, Amelia, Ian, Elizabeth, and Eric, looking at 3x squared and negative 7x. What's the greatest common factor between those two terms, 3x squared and negative 7x? One is between the 3 and the 7. How about between the x squared and the x? Is there anything we can take out of them in terms of the x's? We can take out an x, right? So what we're going to do is, let me move that little rectangle. X is the greatest common factor of 3x squared and 7x. So we're going to take that out and put this up here. Okay, and then how about Emma M, Lily, Amelia, and Ashley? What's the greatest common factor between negative 6x and 14? So what are we going to take out of negative 6x and 14? Yep, we can do 2. One thing that we're going to keep in mind, though, is that we're probably going to need a negative 2. And here's why that I'm thinking forward. I see that this is going to be a negative 7 right here. And since this is a positive x up here, I know the number outside of negative 7x here is going to have to be a negative. And a negative times a negative is going to be a positive. Now, here's the thing. As you're starting it, if you're like, yeah, I'm going to put a 2 here, that's just fine. Okay, and then once you get to this part and you recognize that it's going to need to be a negative number outside at this corner, then you're like, oh, yeah, I probably need a negative number. So we're actually going to use a negative 2, not just a positive 2, right? And then let's go with Ymir, Betsaida, Ian, and Jayla. What are we going to pull out of 3x squared and negative 6x? Knowing whatever this is under this gray box times x gives us 3x squared. So what are we going to put here? Ymir, Betsaida, Ian, and Jayla. You got it. Thank you. And we know that because 3x times x gives us 3x squared. Remember when we worked back on multiplying with exponents, right? And we know 3 times negative 2 is negative 6. So 3x times negative 2 is negative 6x. And then in our last row there, that one gray rectangle that hasn't been moved yet, Chloe, Matthew, Elizabeth, or Giselle, what's going to go here under, what's under this gray rectangle? Knowing I have a negative 2 up in this spot. Thank you. You got it. So once you figure out those greatest common factors, both in the columns and in the rows, that's actually what turns into your factors. If you think about what we did in that lesson before with the algebra tiles, this turns into one of your factors, 3x minus 7, and x minus 2 is your next factor. Okay, so once you figure out what goes on the outside of that generic rectangle, there's your factors. So 3x minus 7 and x minus 2. And again, you can flip those parentheses around, right? I could write it as x minus 2 and 3x minus 7 as well, just as a heads up with that, okay? All right, click the little raise hand button when you are done with this. Again, I'm just going to go back here, Lily, when you said the positive 2 for that greatest common factor of -6 and 14. Do you see why you could start with 2 and then you would just have to switch it once you recognize that this one needs to be a -7, right? Sometimes you got to play. It's kind of like moving puzzle pieces around to make them all fit in the right spots. Okay, perfect. Just wanted to make sure. Thank you. All right, so here's your closure for today. So on your paper, if you could take a moment to do that. What's different about setting up the diamond problems today? And then how do you figure out what x's to use in the generic rectangle? You could certainly draw a diagram on your paper as well. Okay, so the two questions, what's different about setting up diamond problems today? And then how do you figure out what x's to use in the generic rectangle? And when I talk about the x's, I'm talking about how do we know what goes in this diagonal corner, okay? So again, what's different about diamond problems today, and then how do you figure out what to put in the x's? When you are ready, here are the steps for your assignment. Again, if you haven't yet, refresh Schoology for the Unit 6 or Lesson 6. Then there's a worksheet in there like we've been doing. And then when you're finished, take that picture and post it on your DUR. I have not looked at DURs yet to see if you've posted Lesson 5. I know a few of you have, but make sure you get that taken care of as well, okay? What I'll do is actually open up breakout rooms. If you feel confident and you want to go work in your own breakout room, feel free to do so. If you would prefer to stay here in the main room, I'd be happy to go over some of the problems with you guys as well if you'd like. Okay. Any questions before, you can put your raise hand buttons down if you want. Any questions before I open up breakout rooms? Again, if, apparently I can't do two things at once today. Again, if you're confident and you want to go work in your own breakout room, Lesson 6 isn't there for you. Okay, let me look real quick. That happened yesterday with one of my folders. I had the wrong time for it to get published. Let me double check. Oh my gosh, maybe I didn't even post it. Well, that wouldn't be good. It won't take long to get it posted. Ooh. Stop recording because there's some serious lag on my end.